Okay, the final two easy questions, 3E6 and 3E7 from Chapter 3 of Statistical Rethinking, second edition. So here are the questions right here. But before we get to those, just to remind everybody, this is using some code up here, and what this code is simulating is the globe tossing example that we've talked about so many times. Again, so the idea is that we have a globe and we're throwing it back and forth amongst a bunch of people. And the globe is of the earth, and so there's water and there's land represented on there. And every time somebody catches it, their index finger lands on either water or land. And so we throw this ball around a bunch of times, noting where index fingers are landing. And then we use the ratio, or we use the counts of how many times the index fingers are landing on water versus land, and then we're trying to find we're trying to estimate how much of that globe is covered in water. Okay, I've gone through this code too many times now to continue doing it, but the gist of it is that at the end we have a posterior distribution and then samples drawn from that posterior distribution. If you want more in depth, look at the earlier Chapter 3 videos. One addition now is that we need to use some of the rethinking package by McLaren. So this is the code to do so. I've already installed it here. We are using the slim version, which is not the full version. We'll do that in later videos. But before you, if you're using this spreadsheet, or if you're using this Google Colab sheet, make sure that you click on these 3 cells before you continue. Okay. The installation instructions, I'll put a link in to McLaren's GitHub page that explains the installation in detail. Okay. So finally, back to the question. So we, from the code above, we drew some samples, and so now we're asked to summarize the distribution in a couple of different ways. So 3E6 asks us to find the interval for which the posterior probability of P, and here P is the proportion of the globe covered in water. So to find the narrowest interval containing 66% of the posterior probability. And then 7 asks us to summarize the posterior distribution in a different way. So it asks us to find an interval, again on the posterior probability distribution containing 66% of the probability mass. But this time we want to select an interval where half of the wherever we select that interval, what we have not selected, what is outside of that, the probability mass outside of that interval is equal on either side of the interval. So I've taken this image from the book, so hopefully you have the book. But if not, here's this image. I'm also gonna make another example of this once we get through this question. But this is showing a good representation of the difference between what is being asked for. So the first question is at the narrowest interval. This is asking for the highest posterior, what does he call it here? The highest posterior density interval, okay? And so what this is it's taking the highest density of the probability mass, and it's just selecting the highest density areas until we reach 66% of the probability mass. That's what's being asked for in question 6. The other one, which he just calls the percentile interval, PI, again, is, okay, we select an interval where 66%, I don't know, this picture may not be representative of 66%, we'll just use it as a generic figure, but we want to select an interval containing 66% of the probability mass, and then the area outside, so this area to the left, and this area to the right of the interval are of equal probability masses, right? So if I were to weigh, or if I were to take the mass of this white area and this white area, they should be equal, okay? So the code to do this is, for the first one, for the narrowest interval, for the high posterior density, is HPDI. And then for the percentile, it's PI. Now I've dressed this up a little bit with a rounding function so that the output is a little bit more readable, and I've multiplied it by 100 so that what we get out is something percent. So when I do these, so this is the HPDI. So the readout on here is not great, but so this little part and this little part are showing the interval that you have asked for, 0.66, and this is showing the corresponding values of P that represent that interval, right? So a 66% HPDI goes from P equals 50.85 to 77.38. Okay. Now for the PI, for the percentile interval, so this takes, so the PI for 66% means that 17% of the probability mass is to the left, and another 17% of the probability mass is to the right, and the values of P that correspond to those percentiles are 50.25 and 76.98. Okay. So let me switch over here to a different example, just further trying to clarify the difference between HPDI and PI. So hopefully this example is helpful. Okay, so get my pen together here. There we go. Okay, so let's say I'm going to draw a probability distribution here. Okay. Okay, so let's say that this is my values of P, which again is the proportion of the globe covered in water, and then here's my probability density over here. Okay, and so I'm going to make a probability distribution here. And I'm not saying that this is what our probability distribution actually came out to, but this is just a generic one. And we're going to make this bimodal. Okay. So this is the probability distribution. So values here are very likely, and then in the middle not so likely, and then more likely over here. So first, let's come up with a PI. Okay, and I don't, none of this is to scale, but let's say that we're coming up with a 66% PI. Okay. Well, that would mean that on either side of the PI, we want equal probability mass that is not part of the interval. And so it might look something like this. Okay, so everything in that interval is part of our PI. Okay. And that's one way that we might summarize this, but you can see that there's something of a problem, or I mean not a problem, but it doesn't really capture the most probable parts of the distribution, so the PI may be of limited utility. Okay? In contrast, if we wanted the HPDI, we'd want to capture the most probable areas, right? So that might mean that this is part of our interval, or maybe a little bit more narrow, and this is part of our interval. Again, hoping, imagining that I'm drawing this to scale, okay? In which case, these would represent the HDPI,